So your job is you're going to be digging fossils out of sedimentary rock, and once you uncover those fossils, you're going to observe what the fossils are, and then you're going to determine what type of environment they had when they passed away, when they started to form, they died and decayed and went to the bottom on the ground. So you're going to need some tools to do this. What do you think we're going to need for this? Yes.
Goggles.
Goggles. What are the goggles for?
So we don't get sand in our eyes.
Right, so we don't get sand in our eyes. And what are the tools do you think we're going to need? Brianna?
A napkin so we won't spill all the sand everywhere.
Okay, we're going to be very careful because paleontology work, when they're unearthing the fossils, do you think they're doing a really fast job or is it a slow job? Slow, because they don't want to do what to the fossils?
Break it.
They don't want to break it. They don't want to disturb. They don't want to break any piece off that might be important to help them understand where it came from, what type of fossil it is, or any clue that they might overlook if they broke it. So what you're going to do is you're going to get tweezers and a brush, and normally if it was hard rock, you would have a chisel and a little hammer to slowly chisel things away. But ours is in the sediment form, it's not in the rock form yet, so we're lucky. I want the material manager to come and get in the photos for the group only, and then I'm going to call you back up here. Okay, once you have your goggles, if you are observing closely at any time, you must have them on. If you have glasses on and you cannot wear the goggles, that is fine. The glasses will be your barrier, your protection. So you don't have to put the goggles on. Now, if they fit over your glasses, you would like to wear them, you're more than welcome to wear them. But I do not want you to take your glasses off just so that you have your goggles on. Because I want you to see, guys. That's kind of important. I just don't want you to ruin your eyes with some sand hitting it. Now, there not should be any reason sand hits it because we're going to carefully, I'm going to show you how this is done. You're going to take a brush and you're going to carefully move the sand until you come across what you think is a fossil, and then you're going to pull it out with the tweezers. So once you pull that out, then you're going to observe it. You're going to write down your observations on this whiteboard on one side, and then based on that observations about your fossil, you're going to make an inference on what type of environment do you think it came from, or what type of environment did it live in at that time. Everybody understand what to do? Any questions? Okay, material managers, come and get the rest of the supplies. All right. It looks like everybody's ready. I see goggles on. I see all the supplies that you need, except for there's some people that did not get a whiteboard and a marker. So if your group did not get a whiteboard and a marker, make sure you come and pick that up. Now it's going to be whose job to write down the information? Recorder. So you know who you are. You are going to write down the information, all the observations you make, and then the inference of what type of environment do you think it was to live in at that time. So go ahead. You have 4 minutes to work on this. Find your fossil, make your observations, then make your inference on the environment. Go ahead and begin. Remember, you have 4 minutes to find the fossil and then make your observations and inference. I see something.
Looks like an armadillo shell or some kind of armadillo shell. It looks like one of those things that they run to the ground, like a hermit crab or something shell. Yeah. It looks like a shell. We just keep them out of here. Yeah, keep them out. Make sure it's like a shell, Gordon.
It's like a ball. So these are observations. The observation one looks like
This is the engaged part.
it looks like it's
Okay, raise your hand if you can hear me. I need everyone to drop whatever they have in their hand and look this way. If you see your fossil come up, I would like you to raise your hand and share with us the observations that you made. Yes. Is this your fossil? Whose fossil is that? It looks like y'all's fossil. So what are some observations you make? Yeah.
Looks like there's dead fish.
Okay, so that looks like dead fish in that cemetery rock. What else? Yes.
There's more than one.
There's more than one, okay. And what type of environment do you think it came from?
Sand.
Do you think it came from a sand environment?
Underwater.
Underwater, okay. Does it always have to be a sand, like an ocean type environment, or could it be another type of water environment?
Just another type.
Okay, what other types of water environments do we have? Yes.
Fish.
Fish tanks, okay, but before there was not any people.
Oh.
So what else? Ponds, right. What other type of water environments? What other type? Lakes. Rivers. So this could be an example that either came from ocean or lake or a river. So would we need more evidence to determine what type of a water environment it was?
Yes.
Yes. All right, the next one is fossil sample number 2. And y'all happen to have that one, okay? So what are some observations you made?
It happened in different parts of times.
I'm sorry?
It happened in different parts of times.
Okay, because it looks like one fish is on top of another. Is that what you're saying? Okay. What other observations did you make? Yes.
Been by layers of sediment.
Okay, layers of sediment had to cover it up, all right. What type of environment do you think it came from?
Sand.
Okay, but if it's a fish, or it looks like it, does it look like a fish? So what type of environment do you think it's from? Ocean. Does it have to be from an ocean?
No.
It could be from a
River.
or a
Stream.
swamp. It could be from a swamp area, like if there's like a floodplain area. There could be something there. So a water type of environment. Next one is fossil sample number 3. Who has that one? Okay. What did y'all come up with? What are some observations?
A leaf.
A leaf. Okay. So it looks like a leaf. And what type of environment did you say it might be from?
A swamp.
A swamp. It could be from a swamp. What other type of environments could it be from? A what? A jungle, okay? So a jungle, a swamp. Could it be from a place that has trees, so land type of environment? Okay, it could be. Next one, fossil sample number 4. What did y'all have written down? So you're saying the environment is is a water environment, but you know it because it looks like a what? A fish, right. So if it looks like a fish, it probably came from water. I don't see too many fish living outside water, do you? No. Next one, fossil sample number 5. Ooh, okay. What did y'all come up with? Ooh, it looks like an armadillo. It's like a squirrel. Where have you seen this before? That squirrel type of shell. Okay, the beach. And shells, animals that live in shells. So where would you find this type of fossil?
Maybe on the shore or a desert.
Okay, it could be. There's some other types that live underneath the water. So it could be water. It could also be the edge of the water. So this could be found in either place. Next one, fossil sample number 6. What did y'all decide on that?
It came either from a sand or a grassy land
Okay, it came from sand. And why do y'all think that?
because it looks like a dinosaur. A dinosaur is usually in a grassy land.
Okay,
because
so
they need food.
you're saying dinosaurs live in like a jungle type of environment or maybe a land type of environment because it looks like a dinosaur. It has a head, has arms. Right. So do you see how this gives us evidence to our past? Can anyone tell me?
Like they like under something, so they got
Okay, so they died and went to the bottom. And what do you think happened?
like they I'm not say it, but it
Do you think it might have been covered up?
not like it's covered up
With what?
with the fluid, mud, and
Okay, so sediments. So sediments, yes.
It would take a long time for it to be a fossil.
Okay, and so do you think it takes a lot, if you think fossils form over a long time, it's very similar to what other formations? What other formations were we talking about that are very similar? Yes.
Compression and
Oh, and that, right, we have layers of sediment and pressure, and of course there was some heat, but do you think that fossils would be able to survive large amounts of heat? No, it would probably melt them completely, yes sir.
Then like a fish that died and
skeleton could been pushed between rocks.
Okay. What's another way? Yes.
They could have been buried under thousands of layers of settlements to make it oil.
Okay. Ooh, okay. So when they're real small, they could turn into oil. All right. So what parts of living organisms are most likely to become fossils? What parts of the living organisms are most likely to become fossils? Maylene?
Their skeleton.
Their skeleton. Why do you think the skeleton is more likely to become a fossil?
Because insects underground eat the leftovers.
Okay, because they eat all the other parts. The other parts were probably decomposing. Okay, Brandon?
Because your bones don't rot.
Okay, they don't. It takes a long time for them to rot. That could be a good answer. Okay, why are we able to find fossils in sedimentary rocks? Yes.
Because those were, there's nothing like this.
Okay, so do you think fossils form very similar to how sedimentary rocks are formed?
Yes.
Yeah, layers of sediment. What do we need to form sedimentary rocks? What is that? Yes.
Pressure.
Pressure. And what else?
Heat.
Do we need a lot of heat?
No.
No. Yes.
Compaction.
Compaction, which is pressure. What other important thing? What do we need to form them? Cameron? Ooh, lots of time. Yes, it takes time for them to turn into fossils. And then, do we need layers of sediment?
Yes.
Yeah, that's important. And then how does the placement of a fossil in relation to the other fossils help us understand when and where it lived? Think about that one for a minute. Ready? You have an answer?
How big or how small the fossil is.
Okay.
Where it's located, because it could be located in the jungle or desert.
Okay, right. And that's going to give us a hint to what type of environment to have. What if you found like a plant fossil, but you thought maybe it was land, and then you found a fish fossil next to it? Then would you come up with the same conclusion it was land? No, it would be something that lived in the water. Both of them would be. And then what if you found a fish underneath the ground, like the bones of a fish or a fossil of a fish, and then you dug a bit, a few feet up, and you found something that was very similar to a land animal? What would you say came first?
The land.
What came first?
The fish.
The fish. And so the water environment came first, and then what came next?
Land.
Land, right. What? Right. What are scientists who dig up fossils called? Courtney?
A paleontologist.
A paleontologist, and we discussed that earlier, right. All right, so the next activity you're going to do is turn to page 23. Oh wait, most important thing. Put your fossil and hide it back underneath the sand. This is for my next class. Hide it underneath there, and then bring your can back to me. And then I want you to turn to page 23, and also bring your boards and your markers. You are going to dig through different layers today. You're going to select a container to dig through, but that's not going to be the only container you dig through. You're going to see all the containers today. So we're going to rotate them through, and we're going to take about 5 to 6 minutes. 6 usually is the first time we rotate, and then as we rotate, y'all get used to it. You know what you're doing. It takes less than 6. It usually takes about 4 to 5. So I'm going to give you a time limit. Your timer will be up here on the board, so somebody in your group needs to make sure they keep an eye on the time to remind everybody, because if you spend a long time just digging for the fossils, do you have enough time to analyze them? No. So when you get your containers, you have 3 fossils in here. 3 fossils. You're going to use the same tools you used earlier, which is your tweezers and your brush, to dig for them. And once you find all 3, you are then going to look at your identification folder. On the very front, it tells you what type of sedimentary rock it comes from. That also gives you a hint of the environment the fossil was created in. And then I want you to make sure that you write down the sedimentary rock, and then you look for the pieces that fit. When we find fossils, are they always in one complete piece?
No.
No. They're sometimes broken up, and we kind of have to guess where they came from. And the best way to guess is to have identification source. So this is our identification key, and looking to see the measurement is just as important as looking to see if it fits with any of these organisms. And this right over here are the organisms with vertebrae. We have our invertebrates right here. And on the back we have plants. So that's where you look for to identify your fossils. The front, this part, and the back. The front is to identify what?
Rock.
What type of rock? What type of sedimentary rock is it formed in? So type of sedimentary rock, the type of organism right here, and also on the back. Once you've done that, you're going to write them all three. It's going to go on this page. So, type of rock goes right here. The names of the organisms, and how many names should you have there? One?
Three.
How many fossils are you going to find?
Three.
Three. So how many names are you going to have right here?
Three.
Three. And then the habitat, you're going to have to decide. Because sandstone could be from a desert or from a riverbank. If I find a cactus, is that going to be from a riverbank or a desert? Desert. So once you find all your organisms, then you're going to have to decide what type of habitat it is. You are also going to have to write this thing called a depth down. Now it says to order the layers, but we're going to do that later. So you're going to write your depth right here, and that's going to be where? Can anyone tell me where they're going to get the depth from? Yes. Right, it's written on the side of the container for you. So once you get your container, you're going to write this down first. Then you're going to find your what? Fossils. Dig those up. And there's how many of them in each container? Three. And then once you find all three, you're going to do what?
Guess the habitat.
Are you gonna? Can you guess the habitat yet?
No.
No. What are you going to have to do next?
Find what
Find what organism it belongs to after you decide on the rock. Rock first, then the organism, and then the habitat. And how much time do you have to do this in? 6 for each
No.
container, right?
Yes.
Yes. So about 5 to 6 to each container. Y'all start to get the hang of it after the first one. The first one takes a little while. And then right before you switch, you're going to bury your fossils again for the next group to find. Everybody understand? Okay. I need a material manager to come get a container, please. Okay, ready? Go ahead and start looking for your fossils.
These are your keys to use to identify. These are your keys to use to identify. These are your keys
So you have to.
For the depth, 100. Make sure you write down that's the perfect, right? So now we're going to go determine what organism work is. Okay, so go ahead and write that down. They're clean.
So where else?
And this would be still cool again, right?
Guys, didn't I tell you you have one thing? If you have 6 containers and you have 6 lines, can you put them all on on 3 separate lines? So y'all need to reset the line.
You got big.
Yeah, like sandstone.
I know, but there's still
There's also desert, right?
Yeah. You have to add the thing.
I think it would be in the desert.
Make sure you're putting your depth, your 3 organisms, your rock type, and your habitat all on one line. Because you have 6 containers to do. You need to make sure you're fitting all in one line. I want you to go ahead and rotate. After you hide your fossils, hide them first, and then you're going to rotate clockwise. The way a clock hand travels. Okay, raise your hand if you can hear me. So we analyzed different sedimentary rock layers, and they were made of sandstone, shell, siltstone, so many different other types of rock layer. And we found fossils in those rock layers. Which layer is the oldest layer? Yes.
100.
Why do you say it's 100?
Because there are more Tolana and then more and then more and then more.
Okay. Hunter?
Because it's the deepest one, and the deepest one is where you find the more fossils.
Okay, could be, yes.
It does. It says the habitat is a deep ocean, so it might be that a long time ago.
Okay, yes.
There are layers of sediments piling on top of it.
Okay, so you know that 100 meters is the which one?
Oldest.
Oldest, because it's out of all of them, where is it located? At the very bottom. So it's at the very bottom. And what habitat was that?
Ocean.
An ocean. Does that area look like that at 75 meters?
No.
What does it look like at 75 meters? Desert. So do you think this area that we live in today looked like this long time ago?
No.
No. Right back when the dinosaurs roamed the earth, the beach, this was all deep ocean. The beach is all the way in San Antonio, in that area. And then when we had the Ice Age 10,000 years ago, that was actually over the land went further way out because we find mammoth bones around the beach areas. Does that tell you that there used to be just land there and the ocean was even further out? Yeah. So the land has changed over time. And we know the changes occur because of what is left behind.
The fossils.
The fossils. And does that help us determine what the environment looks like? Yeah, if we find fish fossils, we know it belongs to a water environment.
Like places up in Antarctica or places cold. You know, like in the Ice Age, I've seen those the Ice Age movies.
Right.
Whenever they went down there and those
Well, that's
dinosaurs.
an Ice Age movie. That's
Well,
a
like, I was thinking-
that's science
yeah,
fiction. They've taken something that's scientific and they've turned it into
No,
fiction.
but like you know the dinosaurs in there in the ice. could
Right.
They still maybe have the skin on it.
Well, they've actually found mammoths and people that have died and in a frozen area and stayed frozen until they eventually started to thaw out and people found it. And they weren't thawed out completely, they were thawed out enough to where we could see it. And they have to be very careful because then they can see the skin and they can see the other parts of the organism. They don't decay because they're frozen. They don't decay fast enough in that. So they have to be very careful when they thaw them out and look at them. But fossils give us evidence of the environments that have occurred over time. And that area was not always a deep ocean. It turned into what at the end? What was it again at 75 meters? Desert. And what layer is that? Is that the youngest or the oldest layer? The youngest layer. And that's because it's at the where? The top. We're going to look more into this tomorrow.